Okay, so hi, welcome. My name is Luke Kenneth Casson-Layton. I'm the guardian of the IOMA68 standard. It is a certification mark, not a trademark, so I have the interest to branch out in as many areas as possible. So, now, about 3 months ago, on the mailing list for the IOMA68 project, somebody said, oh, there's this Indian group doing their own RISC-V core. You should contact them. So I went, oh, okay, all right. Wrote an email and said, hello, my name is Luke Layton, I'm a free software developer, blah, 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 blah. I'd be really interested to help you to develop a system on chip which does RISC-V and yada, yada, 19 to the dozen sort of thing. And this guy responded. 30 emails later, we got introduced and established that, yes, they have unlimited funding by the Indian government, and I'm quoting here, to piss all over Intel and ARM. The Indian government used to be called paranoid. Now we know they're not paranoid because the NSA really is spying on your processor, an Intel processor, the NSA spying co-processor backdoor Intel management engine, including the switch to called NSA off, whatever it is, management engine off, so that foreign powers do not spy on computers on NSA's own premises. Then we had Spectre and Meltdown, and I'm fairly sure that people are sick to the back teeth of that. So what I did was I talked with him and designed a pinmux for a proposed processor. Now, you can see the URL, Rhombus Tech, RISC-V, Shakti, M-Class. Can we swap to the pinouts tab? Awesome. Okay, so this is generated by a Python script, pinouts.py. It generates the documentation and the technical reference manual, and includes further down some scenarios which test the viability of the whole pinmux design. Okay, so if the pins don't map, then I know that I've got it wrong and I can make some changes. But this took me only 2 days to write. Okay? And adding a new scenario, this one for the Internet of Things one took me 1 hour. Okay? And to give you, to explain to you how significant that is, 5 years ago I tried the same thing here with KeySAD by actually designing the pins in KeySAD and tried testing it. After 2 months, I gave up. Okay. Now, why a pinmux is important is because when you have a processor which has a system on a chip, this is unique to a system on a chip because normally you do Northbridge, Southbridge, and the Southbridge take care of all the I/O. But on a system on a chip, you've got to get it right. You're going to invest $30 million to produce a chip. One mistake, that's it, no customers. Right? Because it does not satisfy the markets that the chip was supposed to be designed for. Okay? So it's very, very important to get it right. So normally you have, if you lined up all of the functions that were available on, say, for example, an OMAP Texas Instruments processor, you would need 2,000 pins to cover all of the functions lined up back to back, right, on a straight through. That is simply hopelessly impractical because what happens when you make a 1,000 or 2,000 pin chip, the die is put on a circuit board where it hits bonding gold wires and uses fusing to melt the wire onto the thing. Now you've got to hit the chip. If you've got 1,000 pins, you have to hit the circuit board 2,000 times. And eventually it causes cracks. And that, once it's cracked, that's it. You have to throw the whole thing out. So the yields are very, very low. So the less pins you can get, the less hammering you need to do, and the lower the cost, and overall lower the cost of the chip. So pinmux is incredibly important. So when you design a pin mux, it has to be targeted at a specific scenario. So that I went back, and designed some scenarios, some schematics, which helped me to test. This is the peripheral schematics. Okay, this tab. Yeah, brilliant. Okay, so on this page, I added a little section about what power management chips are commonly used for system on a chips that I've seen over 6 years of working with PCB designs. So there's a section for those if you need to do one using effectively discrete components, et cetera, different things. And then if your micro SD card needs level shifting, this is how you would do it. You would buy these components and blah, 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 and stuff and things. So there's all these different approaches, and this allowed me to analyze the benefits of each approach when it comes to doing something as simple and mundane as connecting a micro SD card slot to a system on a chip. So sometimes you might not be able to switch the whole of the bank of GPIO down to 1.8 volts because you've got the bank is 16 pins. Only 6 of those are for micro SD. The remaining 10 you need. So you can't switch the whole bank down to 1.8 volts on demand. You have to do it as a level shifting external chip. So all these kinds of things, you have to think about them before you even commit. And it's because this cost is so insane. $30 million is budget money, all right, for producing a chip. So, of course, now that's changing with RISC-V. So this guy is so funny. Yeah, what the heck, I was saying. ARM, very good for you to try to bribe Madhu with $24 million offer. If you'd offered him 240, maybe he would have said yes. All right? This is what ARM is doing, okay? All right? They think because he's Indian that he will take a bribe. Right? It's completely unethical of them. It thinks. So Madhu's family members are founding investors in Google. He is the gateway to the entirety of India for a billion market smartphone, billion smartphones. 100 million laptops in schools, 10 million, 100 million, it doesn't matter, the numbers are so insane. Synopsys and Cadence have offered him free access to $80 million worth of tools, ASIC design tools. TSMC, you do not get access to TSMC, okay, unless you are someone at a Taiwanese company or university, or everybody else has to wait, right? TSMC have offered him access to the multi-vendor wafer testing program at 20 nanometer, 28 nanometer, and 40 nanometer. One free run of chips. The only condition that he is placing is that the entire source code of both the software and the hardware must be Libre licensed. And if any of you who've seen this talk, wish to make yourself an entirely Libre chip, contact me and I can provide you with work in some way to the opportunity. Now, they also have their own fab. I don't know the foundry the process. It's 180 nanometer, and anybody wants to make their own processor, doesn't matter what it is, as long as the caveat is it must be fully Libre licensed. I can put you in touch with them. They will make it for you and send you some chips for free. Okay? All right? This does not happen. This is empowerment for everybody who has been despondent about the costs of doing free silicon, for Libre licensed silicon. Okay? All right? It's just absolutely fantastic. So the only thing is, it's a bit like riding a bucking bronco, because one of the problems with the RISC Foundation is you need to sign, if you want to join the RISC Foundation, you need to sign an agreement which has clear cognitive dissonance in its statements. Section 1.9 conflicts with Section 5.2. Section 1.9 says you're required to push information out to free software people, but you can only do it under NDA and without permission under Section 5.2 because of confidentiality. It's like, so no free software developer will ever join the RISC-V Foundation. No sensible one unless they want to become totally tainted. So there is this clique already, a freaking clique in the RISC Foundation where only the contributing founding members are making the decisions and then doing one-way push out to people like us in free software. All right? I hope you're watching. I hope you fix this, please. Okay, so just talking to the camera. The problem is that because Madhu's group is hardware focused, then they're very, very busy. They're not necessarily focused on the day-to-day mailing list decisions, informal decisions being made on the RISC-V list. So the risk is that they just go, you know what, we got 1 billion population. We can fork the entire RISC-V hardware and software code base. Don't care. Consequences are then that cheap hardware, commodity hardware, starts coming out of India and starts, was manufactured in China, and starts reaching the rest of the world. And they go, I got the Debian or the Fedora binaries. Why don't they work on this processor? It's like, well, because yeah, you get the idea. So this is a very serious thing. I'm sort of landed in the unfortunate position of being the messenger here to ask people in RISC-V to collaborate and keep together and make decisions in a unanimous decision-making fashion. Because the consequences of not doing so are too severe. All right. You've already seen what happened with ARM. ARM 5 years ago, I heard they'd had 720 licenses of different companies. All right. There's no way that you can bring that together. So you have Raspbian, where it's ARM hard float with something missing, so it can't run ARM hard float. And then you have ARM-EL and ARM hard float. Now you've got ARM64, and it's like, this is just, it's chaos. Oh, and you've got the device trees, which don't actually fix the problem. They move the problem to device tree. We need people to stick together on this and not fragment the community by not listening to all of the contributors and all of the parties involved. So anyway, I apologize, it's quite a lot. It's an unscheduled talk off the cuff. 1:34, let's take it to questions. Any questions, anyone? Apologize if you weren't expecting this talk, we were expecting the one before. What else could I talk about? Any suggestions? I know, plug the YOMA68 project. Yes, great. YOMA68, I'm on stand AW building, the old one over there, stand 8. YOMA68 is an eco-conscious computing project, which the idea is that to solve the problems of mass volume manufacturing, of design for manufacture, and design for obsolescence, and designed to allow governments backdoors to your smartphone, tablet, whatever. Oh, and Google to be able to remotely shut down your little home office system. I consider this to be highly and completely unethical, because all of those products will end up in landfill. All right? So that's why I am doing the YOMA68 project, and I would welcome input and assistance in reaching more people to empower people with their computing devices. Thank you very much.
Thanks for your talk.